So now that we know how computers came about, we might be interested in what their constituents are. What is inside a computer and how does it work in general? So you know a lot of computers, of course, you know of computers, and you can see some of the constituents from the outside. So you know the screen, you know the keyboard, you know the mouse, the trackpad on more modern computers. You know about pointing devices like the tablet I'm using. You also know about the network interfaces. So there is a Wi-Fi card. If your computer is old now, you might have an Ethernet card that allows it to connect to the internet with a cable. There might be a CD or DVD reader as inputs. There might be device connectors, so a way to connect USB, FireWire, a new screen, things like this. You might hear the fans and guess that there are heat sinks inside. So the fans help cool down the computer. The heat sinks also the heat sinks actually work like an inverse radiator, so they are in contact with the very hot stuff and expose a lot of surface with the air, and in this way try to dissipate the heat. So you know about all those constituents. You see them from the outside or you can hear them. But there are some more inside. So the most important one is the CPU, the processor, so the central processing unit. That's the most important one, and we'll look at it in detail later. There is another important constituent. It's the memory. And the memory, there are many types. There is the registers, the RAM, the hard drive. So all those different things with different purposes. The registers are in close contact with the CPUs. It's very fast. But as soon as you turn off your computer, that memory is gone. It's wiped out. And it holds very little in memory, actually. The next one is the RAM. It's also wiped out whenever you turn off your computer, but it's a bit slower, still very fast, but it can hold a lot more data. So now you can hear computers with gigabytes or even terabytes of RAM. The next one is the hard drive. So that's even slower. It can hold even more data, and it's So it's all the trade-offs between the different aspects of the memory. And so you can see that the distance here to the CPU increases. Okay, so the distance, the speed decreases, but the capacity increases in this direction. Okay, the next item in a computer is the GPU. So this is a relatively new invention. So it's the graphics processing unit. Basically, more modern computers require more advanced graphics, and this started overcrowding the CPU that was performing other calculations, other computations. And so to prevent that, another CPU, if you want, a second CPU was built or was invented that would deal specifically with graphics. So it helps unload some of the load of the CPU into the GPU. Okay, I should have said already with the processor that there might be more than one, or more than one might be simulated. You've heard of the multiple cores machines. So those tend to have more than one CPU or simulate more than one CPU. The next constituent of a computer is the motherboard. So the motherboard is a very important one as well. It helps connect all the different constituents. So without it, you just have a bunch of stuff that's not connected, and it's useless. But the motherboard is important. It helps organize all the computations, do things like that. And there are many others. There are floppy disk, data tapes, and so on. So this you might not have heard of, the floppy disk, because you are too young, the data tapes because they occur only in some context. So for instance, when you have massive amounts of data, you should use data tapes. At Google, they have lots of data tapes, for instance. Okay, so this is a modern personal computer, one that you can have in front of you at a desk and interact with. But note that many modern devices that you see in everyday life are actually crippled computers. They're things that can perform the same type of computations as computers, but they're just not, that's not emphasized there. So your car might have a computer in it that is just used to decide when the airbag should inflate, for instance. Your phone has a computer in it that might be exploited when you're playing a video or doing different things, but most of the time just does the phone aspect. Your toaster even might have a computer in it. So just to summarize, you could, with all those things, you could possibly, you could program them to compute digits of pi. And actually, this could be one of your projects, to make your phone compute digits of pi. I think the toaster would be a bit harder. Okay, so here's a picture of what really a computer looks like on the inside. I wish I had a hammer and a computer to dispose of, and I could just destroy it and show you. Maybe we'll do that in the next iteration of the course, but here we'll be happy with a picture. So the main thing you will see first is a fan. And the fan stands above a heat sink, and that stands above the CPU. So that's here is the CPU underneath, and we'll see that in the next slide. But there are other things that are interesting to observe. So in general, those rows of little black squares are memory. So here is the RAM. The things that look towards the outside, well, there are device interfaces, connectors, and those things help also connect here the buses with internal devices like a hard drive or things like this. And this might be here, this looks like another processor. It might be the GPU, the graphics processing unit. There are some condensers, some memories, and if you look carefully here, you can see that there are some wires. So all those things are connected with wires that run on the motherboard, and the motherboard tends to be green. That's the usual color that is chosen. Okay, and something that's missing here, if you look at your computer inside, will be certainly a battery, will be alimentation, so yes, so to get the electricity in. So here you see also a battery, a little battery, a pill battery like you might have in a watch. The point of this one is to remember stuff even if you disconnect the computer from the power. So if your battery goes down, you disconnect from the wall or whatever, you plug it back in, your computer still remembers what time it is. So that's thanks to the battery that is used to power some memory. Okay, so in the next slide, we'll look more carefully at the CPU. So here is the same picture as before. We have the CPU here underneath, and I've taken the top part out, more or less. So this is obviously from a different computer, but you can see the fan and you can see the heat sink. So the heat sink, as I said, so if you looked at this one from above, it would look like several sheets of metal and with a dense base at the bottom that connects with the CPU. So you just put it on top of the CPU. And the idea is that this has a lot of surface area. So the air comes in and exchanges the heat with the air, and in this way it will cool down. And so that part cools down and dissipates a lot of heat. And of course that's facilitated by having the fan right above it. So if you think about it, if this is in a cold environment, it will cool down this piece while warming up the air. So it's really the inverse of what a radiator would do. Okay, so now what we're doing is we've removed the piece, the fan and the heatsink, and we're left with the CPU. So sometimes you need to open a little bit of a door, something like this, and then you can remove the CPU. And so this is the CPU, and it has the top and the bottom, of course. So this is the bottom part, and this is the top part. So the top just has some branding. So Intel is a very famous name for computers. For processors, AMD might be another one. This is a 486 computer, so it's a bit of an old computer. So for instance, when I was a boy, I was playing a lot of games on 486 computers. This tells you it's not very new. Okay, so this is the top, and then the bottom, well, you can see, what can you see here? You can see a lot of pins, a lot of electrical connections here, many of them that stick out. And those connections, when you take the processor and put it down, will connect here with a lot of cables that are inside the motherboard. Okay, so because of all the pins, and there are obviously many here, you can see them there, because of all the pins, a common representation for a CPU is as follows. So you have a squarish box, and then you have the pins sticking out. So this is the usual schematics that's given for a CPU. Okay, now you've seen all the constituents, but the next important step is to understand how those interact. So you have, I remind you, the peripheral devices, the screen, the keyboard, the mouse, the network interfaces, all things that sort of connect with the outside. And then you have the processing units, the CPUs, the GPU, and finally the memory, the registers, the RAM, the hard drive, also the DVD in some way. So how do those interact? Well, the computer is digital. So what it will use is the presence or absence of voltage in a wire to indicate a 1 or a 0. Okay, but the presence of or absence of voltage in a wire, as soon as you turn down the power, that's gone. So to allow things to be stored even if you turn down the power, it also uses magnetic fields in a certain medium. Okay, so it uses the two modes, one when the power is on, one for really when the power is off if you want. And it uses that to store information. So the voltage will be discretized, the magnetic field will be discretized, and this is used to represent on-off and abstracted to mean 1 or 0. And this 1 or 0 concept is very important. It's what's called a bit. Okay, so I said the computer is digital, and then I went all the way to using bits. But actually, this is only nowadays. You could have digital computers that are not using bits that are not binary, but this has always been the most efficient way of doing things. So in some way, if you want, the Pascaline, I talked about it earlier, the Pascaline is digital, but uses base 10, so it's not base 2. Okay, so this Pascaline is digital, but not binary. Okay. Right, so those are all very important things to understand. And just one more thing, the voltage in a wire, this might be the way the RAM is communicating, this might be the way with the processor the registers are communicating, and the magnetic field, for instance, that would be present more in the hard drive. So that's how the hard drive stores stuff. If you take a hard drive out of your computer and your MacBook is broken, you take the hard drive out, and then you get another MacBook and you insert your hard drive in there, it will work. Your memory will be transferred from one computer to the other, even though it wasn't powered all along. And the reason is that some magnetic field was staying in your hard drive and remained even though it wasn't connected to power anymore. Okay, now, as I said, the currency within the computer, what is exchanged around is the bit nowadays. So it's zeros and ones. But we don't want to just exchange 0 and 1s. We want to exchange more advanced concepts between the different parts. We want to display numbers on the screen. We want to display pictures on the screen. We want to save data that is more complex than just a bunch of 0 and 1s. So what do? Well, we abstract from 0 and 1 to more advanced concepts. And for this, we need conventions. So there are many conventions that need to be implemented in order to be able to use a computer. You have to use binary encoding for numbers. So if you think about it, you might think that's quite simple. Well, integers, I'll just use binary for that. Yes, but what about signed integers? What about floating point numbers? So there you have to start devising new conventions to encode those objects. You also need conventions for characters. If you type something on your keyboard, the computer has to remember that you type the word, I don't know, computer or your name. So it has to remember about the characters, and it has to have an encoding for the characters in terms of bit. Now you're also giving instructions to the CPU, either directly or indirectly, but those instructions have to also be encoded using bits. So there has to be a whole new convention for the instructions. You're also manipulating memory, so you're saving stuff at a certain place. You need to encode this address using also bits, and there are actually different conventions for different types of addresses. Registers, RAM, hard drive, all those follow different conventions to address them. Now finally, basically each device has its own convention or sets of conventions to encode data using bits. So the screen that I have in front of me, or the camera that I have in front of me, translates images into bits, and this has to be done in a way that can then be transferred to some other place in the computer and understood. Same thing with the keyboard. When I press a key, this has to be translated into bits, or when I move a mouse.